sense. Better. Okay. All right, guys. So the very first question is exactly what the chart is set up for, right? So you're like, thank you, question. You freaking match up with what I know. So there's 1.18 because there's 0. I want to know this area, and it's exactly what the chart tells me. So if I look up 1.18, I get 8810. A lot of 8s and 1s. Go there. That's why when you draw the when you indicate in the picture where your z-scores are and you want to shade the area, and so you know when you're done. I'm done. I shaded the question. That's exactly what I found. Done. Next. Does that make sense? So you want the picture to help you. Okay. So if your height, for example, converted to a z-score of 1.18, you would be taller than 88.1% of whoever people, right? Okay. This guy, same kind of setup. It's negative z-score, so it's going to be down here somewhere. It doesn't have to be anywhere perfect, right? The scale doesn't matter. Just put them in relatively the correct positions. But now I'm going to shade which way? I'm going to shade where? To the right. Okay. So when I look up negative 0.52, when you look up a z-score, you immediately put what you find below what you looked up. So negative 0.52. What area do you guys get? 3015. That sounds familiar. So you can see from the picture's telling you, hey, you haven't finished it. So the people that do not draw the picture, and I'm not forcing you to. I'm not going to take points if you don't, because you're going to make enough mistakes on your own. The people that make the most mistakes are the people that don't draw the picture, because they'll look it up and just circle that shit. The people that draw the picture, you know you're not done, because my question is over here, correct? So then what's this side? Yeah, 6985. Kick ass. Just real quick, just because. I know you have calculators, and I think I told you this again before. What makes this 9, 6? What makes this 9, 9? What makes this 9, 8? What makes this 10, 5? So that's the quick way to do 1 minus any decimal. But you have calculators, I know. Okay. 0, negative 2.63, 1.49. It wants the area that is between. So I really love on this problem that I got some of my favorite sounds to hear in a classroom, which is, oh. Right? So it's a very physical idea, which is weird to us in mathematics. But when I look up 1.49, it's the area below forever. So that's obviously too much, because I only want the area that's in here. And you got 9319, is that right? Okay. So exactly how much area is this too much? It's too much by this much. If I just find out what this area is and subtract it, I'll be left with the area I want. It's a beautifully physical, real-world idea. So what do you guys get when you look up negative 263? 0043? Okay. Now don't leave it like this, because the answer should have one answer. The question should have one answer, so it's 0.9319 minus 0.0043. And what do you guys get? I like it. Kicking the acid. All right. Okay, I like it. And of course, the minute you get used to this kind of thing, I go and do this to you. But again, this chart translates either from Z to percentages or from percentages back to Z, right? So here I give you the percentage. Where will this be? What's 0? 0 would be P what? Which percentile is 0? 50th. percentile, right? So where's the 38th percentile going to be, left or right? To the left. Because it's only supposed to have how much below it? What's this mean? What's this symbol mean? Percentile. 38th percentile has what percentage below it? $38. Thank you. Okay. I know some of you guys are like, it's in the question. That's why I'm asking. I want to make sure you remember that what that means. So 0.38. So really, this is all a question about how nice can you be to yourself. In so many math classes, I've got so many students who are so evil to themselves. They do work all over the damn place, and then they never put it back together correctly. Be nice to yourself, right? Indicate on the picture where things are. That's 0.3. I'm going to put it up here because it's an area. It's going to remind me not to look where the z-scores are. I don't know what the hell the z-score is. 0.38. What's the closest you guys got to 0.38? Did anybody do this one? Yeah, so I see these two here, right? Which one of those is closer? This one is 17 away, right? Now, just in case, you actually could average the two in the middle if you wanted to, just to throw that out there. Sometimes I have people that do that. There are a few places, see the little asterisk places? Do you see how it's perfectly symmetric around that? So if you follow it, they'll actually average the two for you. We'll see that here in a minute, I think, if I remember correctly. So 0.38, the closest one is this one, so I would accept the answer negative 0.31. But you could put negative 0.305. Split the difference because it's almost right in the middle. And just to let you know, a little stats, walk uphill both ways story. Back in my day, when I was taught this, we had to actually do something called linear interpolation and actually do a little formula to figure out exactly where between these two the answer is. Well, let's not do that. That's crazy. Just get the closest. So I got negative 0.31. So that's the z-score that has 38% below it. Okay, I like it. How are you guys doing? So again, if I wanted to know on a normally distributed test who got the 38th percentile, I would go negative 0.31 steps. I'd go 0.31 steps down from the mean. That would be the 38th percentile. Whoever got that score scored better than 38% of the other people. What about this one here? Where is this on the picture? Yeah, 10% above it, so that's 50, so 10% should be way up here. And again, the chart only understands the areas that are below. So what area is below this? 0.9. So let me see. All right, I don't think I quite got there yet. Let's see. So 0.9, what's the closest you get to 0.9? Looks to be right there, right? That's pretty damn close. And that would be 1.28. Where is it that that happens? I guess not yet. So let me do one little thing. Yeah, okay. Let me do one little side note here just to show you one of these little asterisk dudes. What if I wanted 95% below? That would either be 1.64 or 1.65, because aren't these both the same distance away from 0.95? So they're perfectly the same distance. So look what the chart does. Okay, a little asterisk dude, if you follow it, it goes to 1.645. They just averaged 1.64 and 1.65, 1.645. Okay. Kick ass. Kick ass. In general, you just give me the one that's closest, right? Okay. Okay. Now, read number 2 real quick if you haven't looked at it yet. Unfortunately, it should be a lot easier to find a parking spot than it used to be here because we have a lot less students. We haven't quite recovered where we want to be from the pandemic. This semester we're up quite a bit. We're up about 50% in math enrollment, for example. It's crazy. So help me out. What is it in this problem that tells me we're going to be able to use this eventually? Normally distributed, kick ass. So it's got to be normally distributed. Why can't I use this straight up? Like, first off, can you draw this first picture for me? What's the mean in this problem? 33.74. That goes in the middle, right? Why am I not putting a 0 there yet? Because I haven't made z-scores yet. These are all still raw scores is what we call them. We haven't processed them yet. So the mean always goes in the middle. If it's a standard normal, the mean has already been changed into a z-score. That's why it's a 0. Here it hasn't been changed yet, so it's 33.74. Where is 27.2? To the left, 11. And I know some of you guys are like, well, of course it's to the left, but I get people all the time to just sort of put it wherever they feel like it. Where should I shade in? Below this, right? Because less than. So right there, visually, I know the answer should be relatively small. It's at least less than 50%. I know that much. How the hell? I can't look up 27.2 for one thing. Ain't no 27.2 on here. Just to use great grammar. But of course, what 2 things do I need to be able to use this thing? It's got to be normal, and I have to have z-scores. How do I change 27.2 into a z-score? If I do that, it becomes a problem just like this. So I'll do the mean. Oh, man, okay. How do you change 27.2 into a z-score? What's the z-score formula?
Isn't it like 27.2 minus the mean divided by 5%?
Kick ass. So in general, z-score formula is the data point you're curious about minus the mean divided by the spread divided by standard deviation. Yeah, I love it. So z-score is always our data point minus the middle divided by the spread. So take a minute, figure out what the z-score is for 27.2. One big mistake I see people make is they'll do this. I'm going to make a mistake. Okay, right now I am currently making a mistake. I have made a mistake. So somebody will give me that z-score and they'll say, I don't know what to do with that. And I don't blame you. What mistake did I make? What did I divide by 8.63? I only divided 33.74, but isn't that supposed to divide the whole thing? So the little thing about algebra, which is funny, that when we write it like this, we see the big-ass bar. There's an implied set of parentheses there. We don't draw them because we don't need to, because we see the big-ass bar. This dude, thank God, they haven't put little eyeballs in this thing, because that would freak me the shit out. Right? I don't want that. So you have to tell the poor little dude, oh yeah, little dude, you ain't got no eyeballs. Let me do this for you while I continue my awesome grammar. Let me actually put this decimal in the right place. All right, that's better. Okay. Now, I'm not saying that the z-score can't be 23. But at this point in this course, you should all understand a z-score of 23. Can anybody tell me anything about a z-score of 23? Anything. Z-score of 23. Where does unusual start? How many steps away? How many z-scores away? 2. So if I get a z-score of 23, almost definitely you made a mistake. But there's a chance it's true, but that is far as shit away. That is stupid far away. That is 23 times the distance away from the mean as data points get away from average, on average. That is insanely far away. If somebody's height was 23, oh shit, can you do it in your head, Jeff? No. Maybe 55. They would be... Now I have to do it, sorry. They would be 10 1/3 feet tall. If somebody... Yeah, that ain't happened yet, right? Okay, so I need this number. What was it again? It was negative points... What is it? Negative? 0.7? What do you guys think? How many places should we round z-scores to? How many places should we round z-scores to? Z-scores. How many decimal places do z-scores have on this? I love you guys so much. So for example, 0.42, right? How many decimal places is that? 2. So this is the second decimal place. So we're going to always round z-scores to 2 places because that's as far as the chart goes. Okay. 0.76. Don't cut it, round it. I love it. So look that sucker up. What do you get for negative 0.76? .2236. So you can say this a few different ways. There's about a 22.36% chance that a student will spend less than 27.2 minutes a week looking for parking spots, right? That's a very direct way to say it. Here's another way to say it. 22.36% of Grossmont students spend less than 27.2 minutes looking for a parking spot each week. Both of those mean the same thing. Okay, keep going. Do the rest of these. Go for it. All right, guys, I'm going to start to catch up to you. Real quick, chapter 6, section 6.1 is like this. Section 6.1 are z-scores. Section 6.2, they start off as raw scores. You have to convert them to z-scores, right? Okay. So here, number 2, we're still in the same problem. So the mean is still 33.74. I want more than 53 minutes. So it's going to be this little sliver there. And again, as long as you have all the z-scores involved in the problem in the relatively correct place, that's all that matters. We don't know the scale of this perfectly. So I put it way up there. You could have put it here. As long as it's above, that's all that matters. So the very first thing I need to do, I want to be able to use this because it's got all the answers. But I need to have a normal curve, got it, and I need to have a z-score, damn it. So then I have to make a z-score. So I want to make a z-score out of 53. What do you guys get for the z-score? 2.23? Sounds familiar. I'll go with that, all right? So what I normally do is I put the little z-score underneath just to keep myself straight. Back in the day when I learned this, our teacher would make us draw 2 different pictures. And I'm like, you just put a little, it's the same exact picture, it's just this is where this is relative to the mean. So when I look up 223, I'm going to get this, which is not the answer. So what do you get when you look up 223? What'd you guys get? 9871. And of course, to figure out the actual answer, I just have to do 1 minus that. 0129? And again, if you wanted to, you could look up negative 223. Take a second to look up negative 223 z-score. If you want to, I guess. Look up negative 223 z-score. Humor the guy up here. And of course you get, what do you get? You get the same answer, correct? Okay, and again, it's a little shortcut because it's symmetry. It's because the picture's symmetric. If you don't understand it, don't use it. It's sort of like the blinker in your car. Don't use it if you're going to forget it on. You're just going to have the little blinker going forever. Okay. This guy, do you guys notice this problem? Once I made a z-score, it was just like this problem. Not the same, but just like the idea is the same. Here, this problem just like this problem. Here, this problem is going to be just like this problem once I make z-scores out of these things. One mistake I noticed, somebody wasn't careful where they put these things. Both of these are below the mean, correct? So 15.5 and 29.5. So the area I want should be definitely smaller than 50%. Okay, I like it. So I already know that any answer above 0.5 is wrong. I already know that, which is good to know. If I make a z-score out of both of these, what's the z-score for 15.5? What'd you guys get? Negative point, what now? 2.1? Jeff, if you plugged things in correctly. 2.11? I like it. So this is negative 2.11. And 29.5, if you do all the same stuff, what do you guys get? Negative 0.49? I love it. Okay. So again, I think a lot of you guys got this idea. This is why drawing the picture is good, because it's very visual. It's a very physical idea. If I look at negative 0.49, I get too much. I get exactly this too much. So of course I end up subtracting areas to get the area between. So when you look up negative 0.49, what area do you get? I get 3121. Nope. 3121, and then you will look up negative 2.11. I get 0174. Yeah. Okay. So now I just got to do 0.3121 minus 0.0174, and I get what is that? 2947. Is that right? I'm trying to do that in my head. 2947. Kick ass. All right. Real quick. What the hell does that mean? What does that number mean? Sure. Okay. So you could say it's the area between those two, but what's the more real world interpretation of this? There's two main answers I would accept. This isn't a time, right? This answer is not a time. What is this answer? What is it? Physically, what is it? All right, everybody agree that this is the answer, correct? What was the question? Probability that it takes someone between this and this. So what's the probability it takes a student between 15 and a half and 29 and a half minutes per week to find a parking space? 29.47%. What percentage of gross month students take between blah and blah each week to find a parking space? 29.47% is gross month students. Both of those answers mean the same thing, because all probability is it's a relative frequency. Okay, maybe. Okay, I like it. And again, we're still sort of in the phase of how does all this stuff work. So we're still getting used to the chart. We're still getting used to all that. This guy. Okay. First off, 14th percentile. Where the hell is that going to be? It's got to be on the left because this is the 50th percentile. So 14th percentile will be way down there. I'm going to put 0.14 up there because it's an area, right? So let me show you something. Every semester I'm really hopeful this will be useful. So let me try this out. Do you see how every single problem we did up here, weren't we given an X score, right? Every time we were given X's, at least one. Over here we had two of them, right? What did we immediately do with those X's? Change them into Z-scores. And then what did we immediately do with those Z-scores? Found the area, the percentage, right, from the Z-score chart. So this was formula, right? And this was chart, correct? You guys with me? This is a standard little Z-score formula. What's the probability somebody is more than this many feet tall, blah, 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 right? You find a Z-score, you look it up, get the area. Okay. This problem we're looking at right now gives me the area at the beginning. So I'm here at the beginning. So now I got to go backwards. Right? So I've got to use the chart to look up the percentage and make it back into a Z-score. Now, real quick, the formula I used up here was, I don't know if you can see that. There, right? That's the formula I used. Poor little dude. Okay, pretend like that's the right formula. What's the backwards formula? We did this before. If I solve this for X, because now I want to go backwards, correct? What's the backwards formula? Do you guys remember? It was actually the definition of Z-score. So it's mu plus Z sigma. So what does Z-score tell you? The number of these away from this to that. So the number of standard deviations away from the mean to the data point. You can read the equation. It's crazy. So where are we at with this problem? Have we figured out the Z-score yet? No. Did anybody look up the Z-score for this? What's the closest you get to 14%? Say again, sorry.
Negative 1.08.
Yeah, let's see. What did I say? I already forgot. 14? Yeah. Oh, beautiful. That's really freaking close. 1.08. I like it. So down 1.08 steps. Leaves 14% below. So that's the Z-score. And now if I want to make a time out of that, I've got to just use the conversion. This formula is the same as this formula, just solved differently, correct? So whatever form I put the formula in, it can either take an X score and make it a Z, or it can take a Z and make it back into an X. You guys, if you remember algebra at all, this is sort of like the idea of inverse functions. If you don't want to remember algebra, you're fine. You don't have to remember that. So now I just got to throw stuff in. What was the mean? 33.74. It's plus, but then it's negative 1.08, so I'm really just subtracting, right? And the standard deviation was something, 8.63? Yeah. So whatever the hell that is. I always get people that put this, do weird things. Please excuse my dumbass son is still in operation, correct? Or Dear Aunt Sally, or whatever. You guys remember, have I talked about order operations in here yet? Did I say that to you? Please excuse my dumbass son. Or Dear Aunt Sally. Or one semester my class came up with this, deficient algebra skills, right? That was their suggestion, not mine. So what do you guys get when you do this? I think it's supposed to be somewhere around 24, I think. I could be so wrong. 24.41? 42? Okay. So if somebody took 24.42 minutes per week to find a parking spot, they would be in the 14th percentile. In this case, just like a problem from back in the percentile section, you would want to be in a low percentile, correct? You don't want to be driving around forever looking for a parking spot. Okay. So back in the day, we had 20,000 students that would go here. And my God, it still is kind of insane out there for some reason, but it's nowhere near as insane as it used to be to find a parking spot. Okay. I like it. So any questions from this? These are the exact kind of questions I like to give. Okay. All right. So the other side. Sort of don't even just lay it there. Just let it lay there. Give it a rest. Poor little dude. Been writing on its back all the time. It needs a break. We're about to talk about something really kind of weird, and I came up with a way to do it. Do you guys all agree with me that it would be really good to know when I'm allowed to use this? Because these are all the freaking answers, right? So I know every answer for a problem if I know it's normally distributed. Do you guys agree with me? If I know it's binomially distributed, I know the formula for that, right? But if it's just some weird ass funky distribution, I got nothing. I've got to go in and just calculate everything all the way. It sucks. So a huge part about what we're going to be doing for the rest of the semester, every time we hit a problem, we want to know, when is it normal enough for me to use this chart? Because all the answers are just sitting there waiting for me. So, I'm always curious what the reaction's going to be. So we're going to kind of take a theoretical trip to alternate universe Florida. Not the phrase you thought I was going to say. So in alternate universe Florida, let me draw you the age distribution of the people living there, okay? So this is some other universe, right? It's not C-137, it's not 616 or whatever it is in Marvel. Alternate universe Florida. Oof! Here's what the ages look like. Okay. So what does this mean? This means, what does this mean, Jeff? This means I've talked to everybody, or maybe their parents, and I asked them, how old are you, right? I don't get that big of a reaction normally. You guys are all with me? So I went around and said, how old are you? 87. All right, you're there. How old are you? I'm 3. Okay, you were there, right? And the most common ages I saw were whatever that is and whatever that is. Are you guys all with me? What's a little weird about this? This is why it's alternate universe Florida. What's weird about this distribution of ages? So let's say it's from 0, we'll just say it's from 0 to 90, why not? Or let's say 100, why not? We'll be optimistic. What's weird about this? Yeah, so let's say that's 45. It looks like there's nobody who's aged whatever to whatever here for some reason. So I've got a weird take on Logan's Run, if anybody knows that. If not, it's okay. Nobody gets my references, it's all good. So for some reason in this alternate universe Florida, there's nobody from whatever this age is to whatever that age. That's just the way it shakes out. So I go around and I talk to every single person in this alternate universe Florida and I say, how old are you? And I plot them. So why is this the tallest? Because that's the most common answer I got over there. That's the most common answer I got over there. Everybody with the idea. So this is a sample size of 1. Because I went to each individual person and asked them what their age was. And I plotted it. Okay, I like it. So there's a mean. Let's say the mean is 45. Why not? And there's some kind of standard deviation, right? Just there is. Whatever the numbers are, I can figure out what the standard deviation is. Now, in statistics, what are we actually what are we normally working with? Are we working with individuals, or we're working with samples, correct? So what if instead of talking to one person at a time, I talk to 10 people at a time, what would happen? What's the most, is it as likely to get a bunch of people from right here, a bunch of 2-month-olds, right? If there's just randomly picking people, is it likely to get nothing but 10 2-month-olds? Is that very likely? Is that really going to happen a lot to me? No. You guys all agree. Same thing with a bunch of 99-year-olds. Is it really likely that I pick randomly and I get nothing but 99-year-olds? Is that likely? Why not? Because there's so few of them, correct? Is everybody sort of with me? Okay. What's the most likely thing to happen if I just randomly pick 10 people? What is the most likely thing to happen? Will I only get people from over here? What's the most likely thing to happen?
Get people from both.
I'll get a mixture, correct? I'll get some young, some old, correct? That is is it impossible for me to get nobody but just people from over? No, but what's the most likely thing is some kind of a mixture of the two, correct? In fact, can somebody tell me what's the most likely average I'm going to get? If I take a group of 10 people, what is the most likely average of those 10 people? You know exactly what it is. 40-5, right? 45 is the average of everybody. Did I just say that every sample I take is going to have an average of 45? No. What's the most likely average for some randomly selected sample of 10 people? 45. So if I draw a picture where instead of every dot meaning one person, yes? So this dot right there means like a 20-year-old or whatever the scale is. You with me? I'm going to put a dot for the average of every group of 10 people I talk to. So to make this picture, I talked to one person, I said, how old are you? And I put a dot there. And I went to the next person and said, how old are you? And they didn't tell me. And I took their wallet and looked through their drawers and I put a dot there, right? And I'm just rampaging through this alternate universe, Florida. You guys kind of with me? Okay. Instead of that, what if I talked to a group of 10 people and I got their ages and I took an average and then I plotted that? Where should the highest peak be? We just said it. Where should the highest peak be? What age? What was the most likely average to get for any group of 10? 45. So if instead of plotting individuals, what if I plot every average of every group of size 10? What would it look like? It would look roughly like this. Use whatever sound effects you want. Why do I say there would be little peaks here? Because what's the most likely thing is a mixture. The next most likely thing is people around these two peaks, yes? So at 10, there might be these two little peaks corresponding to that. I don't really know exactly what it would look like, but that's my guess. Which one of these looks more normal? Neither one of them is normal. Everybody agree with me? They're both definitely abnormal. Which one looks more normal? The one I just drew, correct? Okay. Which one has a smaller standard deviation? You don't have any numbers, and I don't care. Which one of these has a smaller standard deviation? What is standard deviation again? Average distance from the mean. So all the data points. I love it. So look, ain't a damn soul here that's close to the mean at all. It's going to have a relatively large standard deviation. Here, most of them are right on the freaking mean, yes? So whatever standard deviation this is, this one's going to be smaller than that one, correct? You guys all agree with that at least? Okay. So we got to give it a slightly different symbol. What's really funny is, in the calculator, when you do 1-var stats, can somebody remember exactly what it shows? It doesn't show us this. It's got a little extra thing on it that I sort of didn't make a big deal out of before because I didn't need to, but now I want to bring it back. Do you guys remember when you do one var stats in your calculator, it doesn't say sigma, it says sigma. Let's do a problem in the calculator. Right? Stat, edit, go to your list one. And clear it if there's anything in there, right? Go to list one. Type in 7, 8, 12. Everybody with me? 7, 8, 12 in list one. Now hit stat, calc, one var stats. Make sure it says list one. Calculate. Now, does it just say sigma? Yes, it says sigma x. I love it. So what that means is it's the standard deviation of each of the variables individually. Can somebody tell me? So every plot, every dot here is an individual person. It's that person's age, correct? What is every dot here? Average of 10 people, right? The sample. I love it. So does it make sense the symbol I want to use for the standard deviation for this picture? This picture was created from that one, correct? They are connected. But I want to use a slightly different symbol. I want to use this. That's the standard deviation of the sample means. So this picture is a picture of every possible sample I could get from this alternate universe, Florida. I took an average and I plotted it. Every possible sample of size 10 I could get. I got a lot of time on my hands. Okay. In this alternate universe, I got nothing going on, so it worked out. Okay. So what do you think is going to happen if I just keep making my sample sizes get bigger? Anybody have any suggestion as to, there's one thing you should definitely know for sure based on what we just talked about. If I make my sample size bigger, what should happen, do you think? Standard deviation is going to get... So let me ask you this. Is it more likely I pick one person from here who's 100? Or is it more likely that I pick a group of 10 who have an average age of 100? Which one is more likely? Is it more likely to pick one person who's 100 years old or to randomly pick 10 people who average to be 100 years old? Is it the same likelihood? If you go out right now and you just randomly pick somebody and they're 6'8", everybody with me? What if you go out and you randomly pick 10 people and their average height is 6'8"? The way I'm saying that sort of conveys this, but which one of those two situations should freak you out more? The second one. If I randomly pick people around me and I get an average height of 6'8", I'm like, where am I? Is there some kind of a game going to happen right now that I am not the right height for? What's going on? I got a decent fadeaway, but I don't know. Okay. So what does that mean? The larger the sample I pick, the less likely the average should be away from the actual total average. If I pick one person in here, couldn't their age be vastly different from the average age of everybody? Not vastly, but pretty big. It could be, right? If I pick two people, just two, isn't it less likely their average would be farther away from the real average of everybody? Because what's going to happen more likely is they're going to mix a young and an old, and they're going to average to be close to the average. Here's 10. That's why I drew it so that there's more people near the average. If I take 32, and I'm going to pick that number for a reason. Here's what the picture's going to look like, believe it or not. Here's what the picture's going to look like. Okay, ruffling him back. Poor little dude. He's trying his best. Okay. Anything above 30. You guys notice how slowly I'm talking. That's a good indication. It's a note time. It is definitely note time. Any sample size above 30. The graph of all of the sample averages will end up normally distributed. Let me say that again, and let me write that. sample selection where n is greater than 30, the distribution of all the sample means will be approximately normal. So that normally what I say is it's normal enough. Normal enough for what? To use this thing, right? All the answers. You can kind of get the feel for this from the thought experiment we just did with Alternate Universe Florida. This didn't prove shit, by the way. I don't blame you if you don't fully agree with me, but what we did is we ran simulations on a crazy amount of just data that we fed into a computer, and we had it pick every sample of size 10, every sample of size 12, every sample of size 20. And around 30 is where, no matter what it started off as, once it got past 30, it was normal. Some of them look normal way before 30. If they start off pretty nice, it'll get to normal a lot quicker. If it starts off disgusting, it's going to take longer for it, but normally right around 30 is right after that's where they start to look normal enough. Second thing, let me ask you this. Do you guys notice I kind of inherently did this? Do you guys all agree that the mean of the sample means will always be 45 in this example? There's an average age in here currently, correct? If I take individual people and average their ages, I get an average age. If I took 2 people at a time and took the averages of all the groups of 2, will that number be different? They're the same people. If I take 2 of us at a time, did that suddenly make us all older? Oh, that would suck, right? Stop, Jeff, stop. Okay. You guys kind of with me? So if I take 2 people at a time and average the averages, I'm going to get the same freaking averages. There's an average age in here. I don't care if I take individuals or if I take groups and average the averages. It's got to be the same number. You don't suddenly get older or younger just because I'm doing groups. You guys kind of with me? So the average of the sample means stays the same as it was, but here's the freaky one. And we know this from what I said, and I think you guys maybe agree with me, and I really hope that you understand that I'm not trying to, like, my pictures aren't perfect, but they're capturing the idea. The standard deviation, there's no way this standard deviation is going to do anything except get smaller. The larger the sample I take, the more likely it should be that it's closer to the mean, and that means the standard deviation gets smaller, because the standard deviation is how far away from the mean everything is, right? So the standard deviation gets smaller exactly like this. So this guy, this would equal whatever it was to begin with divided by the square root of 10. This guy would equal whatever it was to begin with divided by the square root of 32. So it just keeps getting smaller as I get bigger samples. Again, if the average age of gross fun is 25, right? And I take 2 people, their average age could be really different from 25, correct? If I take 30 randomly selected people, it's much less likely their average age will be far away from the real average gross fun student age. You guys agree? Is it possible I randomly pick a bunch of really young people? Yes. Is it possible I pick a bunch of really old people? Yes. But the most likely thing is I get a mixture, and their average is close to the real average, right? Okay. And what that means, again, standard deviation is how far away from the average each data point gets. So if everything's getting closer to the average, the standard deviation is getting smaller. It just happens to do it exactly like this. What time is it? Ooh. Yeah. So next time, the whole point of this, maybe don't look at the, well, obviously you can do whatever the hell you want to, but make sure to bring this back. This is a concrete example of this weird-ass theoretical trip to Alternate Universe Florida we took. And of course, now the AC turns off. I love it. So just make sure you bring this next time. We'll do this together. And obviously, we'll have the quiz first. You guys notice, did I say this out loud yet? There's a quiz on 4 and 5 this Wednesday Yay. All right. And by the way, you're welcome, because I don't know if you know this yet, but you want more grades. Do you guys know this yet? Some of you guys look like you don't believe me, but you want more grades, so you're welcome. I'll see you guys Wednesday. Don't forget your stuff. Thank you. Let me uncover it.